Okay, another review on roots and radicals. So the two down here, just do the ones I do. So we got a 50 exponential form. It's 4 would be in the denominator because that's the index, and then 6. I'm fine with that. You could also reduce it in 3 over 2. Okay, 72. There's a 6 in the index. Oh, nothing. So it's 1. 72 to the 1/6 power. Okay, multiplying radicals. Let's put coefficients there. I always like those. And that's a 3-step process when you're simplifying. So 1 times 1 is 1. Then I open up a 4th root and I take 8 times 10, which is 80. Now I start trying to divide because 80 is not a perfect 4th, okay? It's not like those ones where you can just get rid of that, okay? Okay, it's because 80, nowhere to be found, so I divide it by 16, or better divide by 16. There's not a lot of other directions I go from there. So I drop my 1, and I go 16, 5. Get rid of the 4th root of 16, and that's 2. So 1 times 2 is 2, 4th root, 5. Okay. And actually, if you don't put the 1s there, it won't kill you, because that'd be the 4th root of 80, and then you just simplify it. You just wouldn't have a 1 there, but it'd still be 2, 4th root, 5. So that's not necessarily, okay. Now adding, different ball game. You don't add the outers and the inners, okay. You need to make a table, and you need to work on getting the numbers under the radicals to be the same. That's the only way you can add. Now some of you are like, what if I do everything right and they don't add? Well, then they can't be added. Okay, so I tried to dividing into 128 by the perfect cubes. So I would start at, doesn't divide by 125, that's kind of common sense. By 64, yep. So I drop my 2, and I make 2 cubed roots. Remember, it's still times. I don't add till the end of this. 64, 2. Okay, get rid of that. It's not 8, okay? That's 4. So 2 times 4 is 8 with the cubed root of 2. Okay, 250, start dividing. Not by 216, by 125 maybe. Yeah. So we drop the 4 like it's hot, okay? And we multiply the 4. 125, 2. So you delete him because the cubed root of 125 is 5. So 4 times 5 is 20 with the cubed root of 2. Okay, we've accomplished what we wanted to. We got a cubed root with the same number. Don't add the 2's, okay? You got them the same so you can write it down. 8 plus 20 is 28. Okay, now with these exponents, that's a cubed root. So we're going to break that up. Okay, 384, so you got cubes. 384, not divisible. Yup. Nope. Nope. Yup. Okay. So again, 64, 6. Once again, that ain't 8, it's a cubed root, it's 4. Okay, so when I make my new cubed root, I'm going to have a factor of 4 out and a factor of 6 in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're grouping them by the 3's. 1, 2, 3. So x to the 3rd will be outside. And we will just have this lonely x inside. Y to the 3rd, 6. So 3. So that would be y to the 2nd outside. and no y's inside. I need to ditch this marker. It's getting really fat and hard to write with. Okay, as I make these, I don't have a really good writing utensil on me. I don't really care to stop the video and run to the teacher's lounge and have 5 minutes of just nothing. Okay, so we have to solve whenever I see a square root. Do we have operations outside? Yes, we do. 3 in front means a multiplication. So how do we undo multiplication? Probably by dividing. So that's 4. Okay. I got something else here, because that's really crappy pencil. That's 4. So I have the square. Ooh, that's pretty cool. X minus 4 equals 4. Second, I love these when the number's just right there to be taken. X minus 4 equals 16. And that's 20. Easy problem. Fortunately, I can't say the same for the next one we're going to do. Okay. It will be this one here. X minus 8 equals the square root of 3x plus 4. Okay. Now again, square root, no operations outside. So I can go to my second power, but that's a binomial. We got a square. So that cancels, and I got the expression 3x plus 4. That's great, but a binomial times itself becomes a trinomial. 3 terms right there. All right, dudes, so we're going to need a piece of paper here, and we got to take x minus 8 times x minus 8. So the FOIL, 1x times 1x, 1x times negative 8, negative 8 times 1x, negative 8 times negative 8. So that's 1x to the second, negative 8x, another negative 8x. They do not cancel, okay, because they're both the same. So I go 1. If I add 2 negative 8s, that's negative 16 and 64. All right, so I got the 1, I got the negative 16, and I got 64. Now again, don't ABC that. You got to clear this side of the equation. So subtract 3x from negative 16x and subtract 4 from 64. Got 1x second minus 19x minus plus 60. Wow, I had a brain cramp there. Okay, so that's 3 terms. So GCF and the T-chart. I'm going to do the T-charts over here, though. GCF is 1. Okay. So 1 times 60. 60 positive. So it's a sum to get to 19, which is negative. Okay, it's 4 and 15. So 19. Positive means they're the same. Okay, now my A is 1x to the second. So that's 2 answers. So x minus 4 equals 0. X minus 15 equals 0. So I add 4 to both sides, I get 4. I add a 15 to each side, I get 15. Okay, that's how you work those. Okay, got one of them on the next page. 2x to the 6th equals 200. Well, I have x to the 6th only. Okay, so there are 2 answers. Okay, because there's no x's that aren't to the 6th, so I don't need that factoring junk. Now, if I had an x to the 4th and an x to the 6th, yeah, then I'd have to factor. It wouldn't be fun. But I can get the x6 by itself, but it's even, so there's 2 answers. So we're going to need to divide by 2. That's 100. Then to cancel out a whole power, we make a root. Remember, a fraction we reciprocate, whole power we make a root. Okay, so I find the 6th root of 100. So 6 second 100, 2.15. and negative 2.15. Okay, the next one. So again, can't really fit my situation. So I see a power. It's odd. Okay, so there's one answer, but the problem is that power belongs to a whole parentheses. We'll simplify the dang problem by using one single variable, q to the third plus 3 equals 378. Okay, then we'll need the table because we need to bring back the x minus 4. But I don't need this other side because you see there's only one answer. So subtract 3, 375. Divide by 3. $125. Okay, and then I find what the root is. It's got to be the cube root. Now there's a nice thing. You can do it on your calculator, but 125 is a perfect cube, so I'm guessing it's probably 5 if you punch it in right. Yeah, it's 5. So I add 4, and x is 9. Remember, an even power is both sides. An odd power is just one side. If you have a fraction, you look at the top for that little situation there. Okay, I'll do this one here, the FOIL method with the i's. So I take 6 times 6, 6 times negative 1i, 1i times 6, and 1i times negative 1i. 36, negative 6i, positive 6i. I'll cancel those. And negative 1i to the second. So that's negative 1, and that's 1. 36 plus 1 is 37 then. Okay, and I'll do one where I don't FOIL. I just take 3 times 1, 3i to the second. That's negative 1. That equals negative 3. I'm not doing the last one. You don't need to. Okay, let's look at this one. So 3 squared is 7 times 1 squared is 7. So it's just 1 multiplying 3 times. Remember, if you don't, with these roots, if you don't know how to, like whether I need 1 rainbow or 4, do you have any plus operators or minus operators? You don't. So it's probably just 1 multiplication. 3, and that's 49. Now you don't leave that, okay? That equals the number 7. 7 times 3 is 21. Okay, and I'll do this one down here. Now, I do see plus minuses. I put 1s in front then. The 6s are not in front. There's a plus minus. So I FOIL 6 times 6. Then 6 to negative 1. Don't draw a rainbow to the square root. That's all one term. And then 1 times 6. 1 has its square root of 7, though. And then 1 times negative 1, but both of those have their square root of 7. 36, negative 6, square root 7, positive 6, square root 7, and negative 1 with its square root of 49. These cancel. That should not be left that way. That's 7 times negative 1 is negative 7. Then I go 36 plus negative 7 is 29. Multiplying these expressions, I want you to end up with just one number at the end through all the bull crap. Okay, and I'll do a graph, and that's finished as this thing. Do the last graph. Okay. Okay, so, well, again, no asymptote. That's when the x is a power. Here it's just in a root. There is no power. So I'm going to want to pick perfect squares. Again, this is kind of the key point here. That determines the kind of how the arrows go. Now, I would rather not have this plus 6 here. How do I undo a plus 6? Minus 6. -7, -10, -15, and away we go. So -3. Although for some of you mental math whizzes, we got 3 plus 6 is 9. The square root of 9 is 3. 3 times -3 is -9. And -9 plus 2 is -7. You didn't catch how I did that? Okay, no problem. Second, x squared, and then 3 plus 6. Look, mental math's kind of something you're blessed with, or I mean, that's just my honest opinion, okay? I know some may disagree, but it's just like I'm not blessed with a great vertical leap, okay? -3, second, remember, just go second x squared. Don't worry, forget that caret crap. If it's just, if I don't see a number in the index, I'm going second x squared. I'm not messing with that caret garbage. I only mess with the caret if it's not a square root. -2 plus 6. -4. Probably the next one's -1 because these do go in a pattern. Now the next one, if I go up, I'm going to go in the positives, if you can tell. Yep. Then if I punch in -7, domain error scheme. So again, you got to go with this one first, okay? So that otherwise you get all your points crap. You can't remember the arrow, and then you just guess. I don't want that. 1, 2, 3, 4, 5, 6, 1, 2. This is your stop point. You cannot go to the left at all of that because that leads to X values that give you the domain error. Okay, and then -5, -1. -2, -4. 3, -7.